Once again, good afternoon or good evening, and welcome to our lesson on the t-test. We are still on lesson 1, part 2. However, today is the last day for the lesson on t-test, and that's why we are having the part 2. Just a quick reminder of what we did. I'll be very, very, very brief. We talked about t-test. And remember or recall that we talk about normality, we talk about homogeneity, and we talk about the random assignment. That these are the 3 assumptions that must be fulfilled before you can actually do t-test. You know, the normality has to do with normal. The population has to be normal. Homogeneity has to be that there are things that makes them to be common. The random assignment has to do with when you assigned assignment to each of the population. Then we talked about what is the procedure for the normality of population and homogeneity. You can actually get this being done with IBM SPSS, and this is the syntax that you have to follow before you can do the normality test. Then also, when you are doing the normality test, there are these 2 tests that you have to get, and they should not be significant. And when we talk about not being significant means when it is above 0.05. So that is what we meant by being not significant. But if anything that is significant, it has to be within the range or below of 0.05. So, and this is what I also meant by saying you have to note that the population is not significantly different from normal. So that is the Shapirovitch test and the Kolmogorov-Smirnov test, which is also what we call the KS test. Then also to test for your normality, homogeneity rather, or variance, it means you'll be looking at the 11 text, and this also should not be significant. And when we say it is not being significant, we mean that the variances of the 2 groups are homogeneous. That is not significantly different when you say things are homogeneous. Then also, furthermore, once you've passed the test, you can go on to conduct your t-test. But before then, we need to note something when we say robustness of t-test. That is a kind allowing us to violate 2 of its assumptions. You know, there are 3 assumptions, and if you violate 2 and you only fulfilled 1, you are free to use. But if you fail the 3, you can't use t-test. You have to go and use another non-parametric analysis for that. And we also take a look at a non-hypothesis where we stated that there will be no statistically. So why are we using statistically? It is because we are using a statistical tool, and that it is t-test. We want to say there will be no statistically significant difference between, and this word between has to do with 2 things. So between student of dash and student of the dash in the performance of the total score. You know, we want to find the difference in mean of the 2 groups, and you need to state your confidence level or alpha level, which is, it has to be is 0.05. Then further, we go further now to conduct your t-test, and this is the syntax. The syntax is analysis. You click on analysis, you click on compare means, you click on independent sample t-test. Then you insert your test variables and group variables, and you click OK. Then your t-test is being conducted. And also there are 5 simple steps you must follow when you are reporting or when you are conducting your t-test. You need to state your research question. From there, you state your hypothesis, then set your confidence level or alpha level at which you want to test it. Then you conduct the t-test. Then you present your t-test table. Then you state your decision on the hypothesis. Then on the statement or the statement for your decision on the hypothesis, you need to tell us what you found, which is an example is this. Then you tell us your decision. And then it's either you reject it or you do not reject the hypothesis. Then I think that was all what we did yesterday. And now we are going practically right away, and I'll be sharing my screen on what I got from Gloria. Now we did a little things on coding. I'm looking, okay, I've seen it. Yes, we did a little thing on coding, and I want to believe you are seeing my Excel sheet. And she said she's having 67 student respondents, as you can see here, 67. And also, she said she has a factor on gender that she wants to consider, and also a factor on the age group or age range that she's also considering. Then all these ones, they represent the questions that are on attitude that she wants to talk on. However, there is an error or incomplete data set that she has sent. And the incomplete there is she didn't tell us the method, and which is the method. Here has to be with the method. And when we say method, we are talking about maybe this particular student one, she falls under the conventional method, or he or she falls under the experimental method. So that is the method that is missing on this data set. However, I have been able to analyze and I get the method, but she still needs to give me her own method. But based on this, now the question now is, how do you transfer this, all this that she has gotten into the SPSS? And the good news that I can also tell you reliably is you can even use Excel to do some calculations, but that is not what we are talking about. We can even use Excel sheet as it is like this to do correlation, to do the t-test, to do the regression analysis, and all of them. But it's few people that knows how to do that. And thank God I happen to be one of them that can use all those statistical tools, even in your Excel, to do whatever calculation. But however, what we are using is SPSS. And how do you transform or you transfer all these things into your SPSS? It's quite simple. You ought to have opened down your SPSS. As you can see, I'd already transferred all what she's having in an Excel into the SPSS sheet. Let me share my screen now so that you can see the way I have it there in the SPSS. Now in the SPSS, this is it now in the SPSS. So how do you do that? What you just need to do is just to copy all what you have inside your Excel and you paste it here. And you have the data view, you have the variable view. So you paste all those things in the data view. And as you can see, you see here, you have C1, C2, C3, C4, C5, and all of them. You can see here 5, 2, and all of them. So immediately as I can see this, it's telling me that this is 5 levels of Likert scale. This is 5 level. This is the highest, and this is the smallest. Merely looking at it, I can easily see. And for my move method, you can see my method. I said the experimental should be 2, while the control is 1. As you can see, if you check down through the method, you will see 1, 1, 1, 1. I'm trying to see where the intercept. You can see here, the method here is 2, signifying that it is experimental. Then here it is 1, signifying that it is control. Now, if you go to the view variable, I want to believe that you can still see my screen. I want you to answer. Can you see the variable view? Answer.
Yes, sir.
Yeah,
Yes, sir.
Exactly.
Okay.
Now you can see gender. You see gender, you see age range, you see method, and you see C1 down to C17. And here you see total attitude. All these are the calculations I've done behind. Now, if you go back to your view, you can see the gender up here, you can see the age range up here, you can see the method down to 17. Then you'll see the total attitude scale or total attitude. Now, how do I distinguish between male and female? That is the question in the gender here. How do I distinguish between 09 to 010 and 011 to 012? That's the question here. How do I distinguish between the method? Which one is conventional? Which one is experimental? All these are done inside this value here. This value you can see. If you click the value, if you click on the value, this is what to show. I want you to please, when you are joining, try as much as possible to mute, please. Yeah. So if you look at the value labels here, you can see my value. My value is 1. I'm saying 1 should represent male and 2 should represent female. That is what I have at the back here. And that is how to do it. So now also for the age range, I've placed value for them as well. If you click on it, what will show is just value and label. What value do you give for your label? Because up here, at the back here, you can only see zeros and 1 and 1 and 5 and all of them. For gender, you see 1. Anywhere you see 1, it is male, and anywhere you see 2, it is female. Anywhere you see 2 or anywhere you see 1 for the age range, I've already specified my age range. Then also for method, anywhere you see 2, there's a reason for it, and anywhere you see 1, there's a reason for it. Also for my C1 is a question. So both choices are what the are what the participant have chosen here. I'm trying to lump so many things together. The reason being that we are now doing statistical too, but there ought to have been some tutorial that tells you how to do all these ones. But I want to assume that you know them. But because I still also want to assume that you don't know, I'm trying to explain so that you get what is happening at the variable view. So if you look here too, for the method, you can see for the value, I've defined my value. I define my value as number 1 to be control, as number 2 to be experimental. If you click on it, you will see this is value, this is the label. So then also now for all the questions that I asked on the attitude, I give a value for them. If you click, you'll see I say strongly disagree, because the more you agree, that means the more you agree, the more mark you have. So you can see for my strongly disagree, I've placed a value of 5 for it. So what does that mean? And I also place a value for my agree. I place a value for all other labels. If you go back and you look at it, anybody that choose 5 means the person has said strongly agree. Anybody that choose 4 means the person has said agree. The person that agreed to this question on 4, the person that agreed to this question on 3, on 4, and so on and so forth. Now, for my total value here now, for the total attitude means if you calculate all these labels here, everything you have here should be equal to 50. That is what it means. All the value here, all these ones, the ones are highlighted from C1 to C17. If you do your calculation, it should equal to 50. The same thing here, the same thing here, the same thing here, and so on and so forth. That's how I got the total value for the attitude, because we are measuring their attitude now as against their age, as against their sex, and so on and so forth. Whatever things you want to do the calculation of. And the first thing I want to do here now is, how do you have a total value? How do you do the calculation for your total value? It's very simple. What you need to do is you go to your transform on your SPSS, and you click on compute value. You click on it, compute value. And as you can see here, you can see what I had computed on my value already. I added C1, C2, C3 down to C17. And in here, what is the target variable? This place will be empty. And I hope you can see my screen where it's showing compute variable.
Yes,
Hello,
sir.
class.
Yes, sir.
Can you see where you have compute variable, where you have C1 plus C2 plus 3? Can
Yes,
you see
sir.
that?
Yes.
Exactly.
Yes, sir.
You can see everything I have inside my SPSS is what I have here. I will type my target variable here, which is total variable, total attitude. Then I will click on each of these items. Once I click, I say I'll place it in here, and I will add plus. Plus this one, I place it here, plus this one, I place it here. That's how I got all this. Then at the end, I click OK. The moment I click OK, the system does this calculation for me at the back. Now, the next question now is to begin to work with your hypothesis. You have asked you to go and do the research questions, and what are those things you got? Now, this is where it will show if actually what you've gotten for your research questions actually tally with what I have. So what is the first question? Now, let me unshare and share what you have for your inside your notes. The first question here, and I believe you can see my screen. The first research questions here say, what is the multiplicated factor in the teachers-pupils relationship? I've told you what to do about this, and you've gotten some things done. But however, I'm going to use statistics. Mean ranking is what you will use here to compute that. But I'm not going into that. And mind you, all this research, all your research questions and your research hypothesis will definitely change. It will change. Because based on some calculations I did at the back, I discovered that some of them, or even nearly all of them, will change. Now, let me now begin to work from the right angle. I'm not going to be using all this, your research hypothesis and all of them. Let me unshare and share my screen back now. Let me share my screen. Let's go back to our statistics. All right, we are back. Now, the first thing that we need to consider is we want to check if there is a significant difference in male and female. That is what we want to calculate now. What is the significance? Is there, the hypothesis says that, is there a statistically significant difference among male and female when you use the method? The methods, note that. Is there a statistically significant difference? The question we are asking for our hypothesis states that there will be no statistically significant difference between male and female. You note that there will be no statistically significant difference between male and female. And if you look at what you wrote is wrong. So the right thing to write is, there will be no statistically significant difference between male and female in attitude. You get that? In attitude. Yes, in attitude when using the methods. So you note that I'm recording this, you can watch the video again. So now, how do we do the calculation? You click on your analysis. First and foremost, you need to consider, you need to check for your assumptions. Maybe if you can use the test to actually do that calculation. You go to your descriptive statistics, you go to your explore. We want to check now, can I use a t-test to check that hypothesis? That's the next question you ask yourself. You click on the explore, and remember that you've gotten your total attitude. Let me reset this. You've gotten your total attitude. We want to check, is there a statistically significant? There will be no statistically significant difference between male and female. That is what we want to check for. So what you will put your gender will be your factor. Then, because you are considering attitude, and the attitude you are considering is all this attitude, all these ones, and you've added the attitude here, which is what you are having in this total attitude. That is what you put here. That is your dependable. Sex, you cannot change sex. So their attitude is depending now on the sex. So you want to check which attitude, is there a significant difference between male and female? And that is the gender which you have here, which means you put your dependent variable, which is your attitude, then your factor that you are considering is the sex, which will be here. Then you go to statistics. Let's see, maybe, yeah, it is still on 95%. It's okay. What do you plot? We are plotting the normality plot. We want to check for normality. Why are we checking for normality? We want to be sure that the population we have is normal. It will tell us if it is normal, it will tell us if it is not normal. Then you click on transform, after which you click continue. Once you say continue, let me see option, you are okay to go. Then you click OK. Once you click OK, it does the calculations for us. So let's take a look at what is doing the calculation. It will display it down here. You can see total attitude by gender. That is what it's trying to do for us. Now it has done it. Explore, you see explore, then you see gender. It's telling us that we have 30.
We are not seeing this. We can't see the screen,
all right, thank you. Let me unshare and share. I'm sorry. Now you see explore, you see gender. The statistics, the system is telling us that we have 35 male, 32 female. None is missing and all is 100%. So none is missing here. You can see missing case, nothing is missing. You can see total, which is 35, 32 is 100%. So nothing is missing, no one is missing. Then you go back, you scroll down to your normality test. As you can see, our assumption says that your normality should not be significant. And when it is not significant, what does that mean? It means that your population is not significantly different from normal, meaning that your results are not significantly different from normal, meaning that your results are normal. That is what it means. You can see Shapirowick test for male, it is not significant because it's above 0.5. You can see the also for female, you can see that it is above 2. So we are good to go. For normality, we pass it. That's what it shows here in this data set. We pass our normality test. Now let's take a look at our homogeneity test. You can see for that also, the one I said you'll be looking at based on mean. You can see it is the significance there. It is also not significant. It is not significant. So we are very, very permitted to use t-test. That is what it means. So congratulations. So for gender, you pass normality test, which you will report Then for homogeneity test, you also pass it, which you will report. That is just how you do it. So you report this table and you also report this table. So meaning that you pass both normality test and the homogeneity test based on your data set. The next phase or the next thing you need to do now is to now go to your t-test to see if truly there is a significant difference between male and female in the data set. How do you do that? You go to your analysis, you go to compare mean, and you now go to independent sample t-test. That is what you will use. And what you will now be looking at now is gender and the total attitude, because you are looking at, you are trying to say that the attitude, you want to compare if there is a statistically significant difference between male and female in their attitude when the methods are used. The method that I'm talking about here is both for control and for the experimenter. So you move your attitude to the test variable here, which is what you have here. Then for your grouping variable, what you are considering is gender. So you move that one here. And remember, I told you, you need to define your variable. You click on the define group. And for group 1, remember you've said male should be 1. And for group 2, it should be 2 for female. Then you say continue. Let's see options. Maybe you have anything. You make sure it's still on 95. You say continue. Then you click OK. Once you click OK, the system does the calculation for us. And you wait for some seconds. Now it is done. If you look at these statistics now, what you are going to report, you will report the group statistics. You will label it and report it. You can see even from the statistics that for male, you are having a mean of 49.0571. If you do two decimal places, this will give us 49.06. So while this one will give us 47.00. You can see that the mean for the male is more than the female. Remember, I asked you to go and do your own calculation. If what you've gotten is different from what I am getting, that means you've done a very big error, a wrong thing. That is what you've done. If you look at it here also, if you look at the standard deviation, deviation is, remember when I told us what deviation, standard deviation is how far the mean is to each of them. You can see this one is nearer, this one is a little bit far, but you consider the mean. The mean is saying this male, they did well in terms of their attitude, in terms of male and female attitude. Male pay more attention. That's what it means. Male, they pay more attention than to female. That is what this statistics is telling me here. And you will report this table. You only report gender, end group, mean, and the standard deviation in 2 decimal places. So if you are putting this in 2 decimal places, this will be 4.62, while this one will be 3.72. That is what you'll be reporting in your statistics. That is how you do that. And when you now go over here, come over here to report your hypothesis, this is what you will use to report your hypothesis. Remember, I've given you the syntax, the way you need to report it. If you now look at it here, you can see that this is significant. This is a significant value, exact significant value. You will report the way I've told you the syntax, where you say open bracket T, open bracket 65, then you close the bracket, is equal to what you have for the t-test. This is the t-test. Yeah, what you have, which is T, that is the t-test, is equal to, you approximate it also to 2 decimal places. Then you now say colon, P is equal to, you can write this out as 0.05, or you say is lesser or you can decide to say it's lesser because this is equal to, or maybe you just report it and say is equal to, write this value out. And you can now state on your decision that it is significant. And because it is significant, that hypothesis which you've reported that there will be no, you've already said there will be no statistically significant difference. And now we are getting a statistical significant difference. So you knew what to state at your decision. That is for the gender. You can see we've done now for the gender. The next one we want to do is for the age range. And you need to test also for your assumptions. Maybe you can use the test for that second hypothesis. So what do? You go to your explore, you reset what you have here. What you are treating now is the age range. Age, you put that as your factor. Then you go to your total attitude and you put that as your dependent. You go to your statistics, make sure it's still on 95. You say, okay, go to your plot. What you are testing for is normality with test. So you now click on untransform. Remember, we are doing for age range. You now say, okay. You've highlighted all this, you now say, okay. Let's wait a while. System will do the calculation for us. You can see attitude by age range. So now you see the system has done it for us. It's telling us between the age range of 9 to 10, you have 34 of them. And between the age range of 11 and 12, you have 33 of them. No one is missing, and the total is 34, 33. For 9 to 10, you have 34 respondents. For 11 to 12, we have 33 respondents. Now let's check for our normality and also for homogeneity. So for our normality, you can see we passed it. Yes. You can pick for Shapiro week. You can see it is not significant. This one also is not significant. But for Kolmogorov and Smirnov, this one, you can say it is not significant too, because if you approximate this will give you 5, which you can still manage that it is not significant. Then also here, it is not significant. So we are good to go for our normality. What about for homogeneity? You are looking at it based on mean. Look at it here, it is also not significant because this is far, far above 0.05. So we are good to go. Indirectly, we pass our assumptions for normality and for homogeneity. So the next thing we need to do now is to conduct our t-test. So the t-test is permissible now for us to be used. You click on your analysis, you go to compare mean, and you go to independent sample t-test. And we are considering age range. Age range is what you will put at your grouping variable. Then you will now put your total attitude for the test variant, test variable. You need to define your group. You need to give your group 1 and your group 2. You say continue, and then you go to option. Is there anything? It's still on 95. You say continue. Then from here, you say okay. The system will calculate the t-test for us. As you can see down here, the test has been calculated. Now, you will now discover that it is the age 11 to 12 pay more attention. Their attitude, they paid more attention as compared to the age 9 to 10. And physically, if you see, the older you become, the more you can give attention to people. And that is what the research work is doing. And I must tell you, this is a great research work. It now depends on you to support your data with enough empirical, enough literature. I've given you one just now. The more you grow, the more you tend to give more attention to people. Like if we have all those small babies and you are talking to them, they might not give you attention. But when you have older baby, they tend to give you attention. And that is what your research work is giving you here. So you can now begin to see, oh, this is true, this is true, this is true. Now, if you look at here, if you could do it to 2 decimal places, you can have 47.88. 2 decimal places, you have 48.27. Then you also give 2 decimal places for your standard deviation. Now, if you now look at the t-test here, the hypothesis says there will be no significant difference between those age range. There will be no statistically significant difference. And truly, because you've said there will be no, you are actually seeing no difference because it is not significant. So that hypothesis, you do not reject it because it's coming out to be true. That is what you have here. Then you also have your syntax to state that T open bracket 65 close bracket is equal to what you have here. What you have here, you can equate this to 2 decimal places. Ignore the negative sign. This is for another research talk, but you are not going deeper into that because you are having negative here. It's another indication in your study. So, but you just equate this to 2 decimal places. That will be 37. Then it's equal to 37 colon P is what is, you can write this out or you say is greater than 0.05. And what is your decision? Your decision is you do not reject the hypothesis. What does the hypothesis say? It says there will be no statistically significant difference between age range so and age range so. And actually, we are not seeing any significant difference. So you brought your findings and you do your decision. Now, the third one, which you will do, is the one that has to do with there will be no statistically significant difference between the control and the experimenter when you are using the method. No, there will be no statistically significant difference between them. So, and how do you do that? You want to check for the method. So you go to your descriptive and you check first if you can use, you want to check for the method. So you need to check if you can use the test for that. And that is the method. So the method will be your factor. And then your dependent variable will be your mean, which is what is here. So you do your statistics, it's still on 95. What are you plotting? You are plotting your normality, and also you are checking for your homogeneity. So you say, okay, here, and let's see what the result is giving us. It's looking at the attitude by their method. You can say for the control, it says you have 30. For the experimenter, you have 37. No one is missing, and the total number is accurate. So if you look at the test of normality, you can see we are good to go. You can see it is not significant, then we are good to go. Then for homogeneity test, it's also the same. It's also the same thing. We are good to go because here is significant and it is based on the mean, it is significant. Now, the next thing to do now is to test with the t-test hypothesis that you've stated. So you go to your compare mean, you go to independent t-test, and you put your grouping variable here, which is your method, and you group them. Remember, you've given your control to be 1 and your experimental to be 2, and you say, okay, then based on the test variable is what you put your test attitude there, and that is it. You check for your options, you make sure that it's still at 95, you say okay, and you say okay here. Let's see our result. Our result is saying that for the control, you have 46.96, and which is approximation of 46.97. And for the standard deviation is 4.00. And if you look for the experimental, you see that for the experimental is saying you have 38 participants or student or respondent. Then for your mean is 48.97 also. Then for your standard deviation, you have 4.38. And from here, you can deduce and say, oh, for the fact that the mean of the experimental is more than the control, it means actually your control, and that control is the teacher-student relationship which you are doing. So you can easily say here that the teacher-student relationship which you are experimenting with, they performed better to the experimental. I mean, perform better to the control, mind you, more than the control. Your experimental group, those are the group that you are using the teacher-student relationship experiment with than the control, which is the normal teaching method. And truly, in life, if you pay attention with someone, the person tends to perform better. So, and your research also is saying the same thing. So you are indirectly contributing to literature that this experimental work is good, that you now begin to encourage and state there that teachers are encouraged to follow suit. Then you back it up with literature. And if you cannot get enough literature, what you just need to do is you need to speak, you need to think deep and speak to your research work. And if you look at it here, if you look your hypothesis here, you now say, you remember that your hypothesis says there will be no statistically significant difference. And truly, if you approximate this is 0.06. So this is not significant because why? It is above significance. So you do not reject because you stated your non-hypothesis that there will be no, and truly there was no. So you do not reject your hypothesis. So those are the those are the three hypotheses which you will have. You can see it has already negated your three hypotheses that you have. So the first one is there will be no statistically significant difference between male and female in their attitude towards teaching of something. You get me? There will be no statistically significant difference between male and female in attitude towards teaching. Remember, I told you, you will pick one subject to teach, and that is mathematics. Teaching mathematics. There will be no statistically significant difference between male and female in attitude in learning or in learning and teaching mathematics. That is your statistical, that is your hypothesis. Then the second hypothesis is there will be no statistically significant difference between age range in attitude towards teaching and learning mathematics. Then the third one, it will be similar to what you have, and that one will be there will be no statistically significant difference in attitude of pupils towards learning mathematics in teacher-pupil relationship and conventional method. So those are the three statistical research hypotheses that you will state in your work. So, and because here too, you've seen what you'll be using to solve your research questions. All these ones, like these group statistics, will help you to solve your research questions. And you are having 4 research questions. So already you've done the first one. So these ones will help you to do your other 3 research questions. And that is what we have for today on the Let me stop the recording.